Hey guys, this is the second video for your independent study unit. This is what's your type? Today our learning goals are going to be able to classify the types of chemical reactions by looking at the products and reactants, and then also classify reactions based on electron movement. So there's three ways to classify reactions based on the movement of electrons. So a type of reaction. There's many different types, but they can be broken into these 5 major types of reactions that we are going to focus on mostly in this class. Those are synthesis, decomposition, single replacement, double replacement, and combustion reactions. And it's fairly easy to just look at a reaction and be able to classify which of those 5 categories that it falls into. So what you're going to be looking at is the reactants and the products. So we're looking to see, how do the reactants change? Do they come together to make one product? Do the reactants break apart to make more than one product? Do they switch partners? Those are some of the things that you're going to be looking out for. So the first type of reaction is a synthesis reaction. And based on the word synthesis, this should be fairly easy or intuitive, I guess, to classify. If you have 2 or more reactants and they come together to make one product, that is synthesizing. You are making something new from something you did not have before. So an example of that would be if you have magnesium reacting with oxygen, you produce magnesium oxide. If we were to break this down into the chemical formulas, or actually write the equation, magnesium is just Mg, oxygen is diatomic, so it's O2, and magnesium oxide is MgO. If you pay attention to your swap and drop rules, the charges on those things simplify and we get MgO. So we take 2 reactants, they come together, and they make one product. That is a synthesis reaction. Next, we have a decomposition reaction. This would be the opposite of synthesis. This is where you have one reactant on the left and it breaks down into its individual components. So an example of that might be H2O, or water, breaking down into hydrogen gas and oxygen gas. So H2O yields hydrogen and oxygen gas, and obviously this is not balanced. So you would need to go ahead and take care of balancing that reaction as well. So the molar mass is decreasing of the individual products. The molar mass of the individual products is going to be less than that of the reactant. Our next reaction, a single replacement reaction. So think of this as say a couple is dancing and then someone comes in and steals your partner. So this is a compound reacting with something that is not in a compound, so just an element or a diatomic molecule. And then that single thing comes in and steals the partner. So here E is with F now, and D gets kicked out by themselves. So an example here would be iron, which is the single thing, reacting with copper 2 sulfate, so that would be CuSO4. And then the product of that is copper gets kicked out to be by itself, and iron takes over the sulfate. So then we have Fe2SO4. So those charges cancel out because sulfate is a 2- as well. So notice that the iron replaced the copper and kicked copper out to be by itself. This is a single replacement reaction. So then we can go on from there and think, well, double replacement reaction. So a double replacement reaction would be like 2 couples switching partners. You have 2 compounds, and then they trade partners to make 2 new compounds. The thing to watch out for here is the cation, the positive one, and the anion can only ever switch partners to be a cation and an anion on this side. So notice, if G is positive and it switches partners with something in this compound, positive cation G can only go with the J, because we can't have two cations together. So they have to switch partners in a way where the cation and anion pair up. So here's an example. We got lead 2 nitrate, so that would be Pb, NO3 in parentheses with a subscript of 2, reacts with potassium iodide, so that is Ki. These things switch partners, and the K and the nitrate go together. So now we have KNO3 and lead 2 iodide, so PbI2. So they've swapped partners. Something to look out for in a double replacement reaction, which we'll cover in the next video, is you also have to pay attention to these things called solubility rules, or aka the formation of a precipitate. And what a precipitate is, these two reactants are both what we call aqueous. That means they're things that are dissolved in water, so they appear to be liquids. So we have two clear liquids or clear-ish liquids, and when we react them together, we pour them together, we get a solid that forms. So in this picture, this is like a clear liquid being poured into another clear liquid, but the chemical reaction actually produces this cloudy solid stuff that if we let settle would settle out to the bottom. That solid stuff is called a precipitate. So if you have a solid form, when you mix two liquids together, you've got a precipitate. And we'll cover that in the next video, the solubility rules and how you can predict whether or not a precipitate will form. And then the last of those 5 main types is called a combustion reaction. We talked about combustion reactions in class a little bit when we were doing a preview to balancing. So a combustion reaction is anytime you have this thing called a hydrocarbon, which is just a mixture of some compound that has carbon and hydrogen in it. Sometimes this will also have some other element in this compound, like oxygen or nitrogen. So you have a hydrocarbon reacting with oxygen, and that should be a 2 there, reacting with oxygen, and the products of these reactions are always carbon dioxide and water. So those are easy to recognize, because if you have carbon dioxide and water as your products, and oxygen and some hydrocarbon as a reactant, then you know you have a combustion reaction. So an example of that would be methane, CH4. You would not have the skill to be able to tell me that methane is CH4. That's something you learn in organic chemistry. Reacts with oxygen, diatomic, O2, to produce CO2 and H2O. So that is a combustion reaction. So those are your 5 main types, and here's your opportunity to practice. I suggest pausing the video for just a few minutes and seeing if you can identify these, and then resume. I'll go ahead and answer this now. So for number 1, we have a single element combining with some compound to produce another single element and a different compound, and I'll notice that these guys have essentially just swapped places over in the products. So this would be single replacement. Then I got CH4, so that's a hydrocarbon reacting with oxygen to produce carbon dioxide and water. That is combustion. Here I have a compound on my reactant side, and it looks to me like that compound breaks apart into multiple pieces on the product side, so this is decomposition. Then we have 2 reactants, so iron and oxygen, but they come together to make only one product. That is synthesis. And then lastly, I got a compound reacting with a compound. Then that produces a different compound and a different compound. And hopefully you can tell that we've got some swapping of partners, especially if you write this as HOH. You can tell that the H and the Na just switched places. So this is double replacement. So for this one, describe the types of reactions involved in the isolation of copper. So you can read through this statement and then write out the equations that are described here and figure out what type of reaction, which of the 5 types. I am not going to answer this one for you. However, if you have questions, you can certainly ask your teacher. Okay, so chemists actually don't use those 5 major types to classify chemical reactions. They're more concerned with the movement of electrons and identifying where and how electrons move. So there's a better system, or a different system rather, to classify chemical reactions. Other than defining those, we're not going to use them too much in this class, but you should be able to at the very least, define these 3 other types. The first one is called oxidation reduction reaction, sometimes abbreviated as redox reactions. Of those 5 types, these 4 can fall or fit within the redox reaction type. There's a neutralization reaction. Double replacement reactions fit within that category. And then there's precipitation reactions. Double replacement reactions also fit within the precipitation reaction category. So these are the 3 main ways that chemists classify reactions. And again, we're not going to use them too extensively in our class, but a definition from you guys is all that I would expect. So for an oxidation reduction reaction, we're looking for the movement of electrons, and they're usually pretty easy to identify if you remember how to assign oxidation numbers. So if I'm looking at this, I remember there's a rule that says all elements have an oxidation number of 0, and then all ions have an oxidation number equal to their charge. So in this case, this is going to be 3+. And so on the reactant side, in order for iron to go from a 0 oxidation number to a 3+ oxidation number, there had to be a loss of electrons. So to get from here to here, electrons were lost. And that is what we're looking for to be able to identify if we have a redox reaction. Precipitation reactions. I mentioned this in a previous slide. This is if a solid appears in the solution when there wasn't one before. So if we mix 2 clear liquids and we get a solid produced from that, then that is called a precipitation reaction. These are our double replacement reactions, are the ones where we see precipitation. And in the next video, I'll teach you how to use your solubility rules so you can predict whether or not a precipitate will form when mixing 2 aqueous solutions. And then the third type is a neutralization reaction. This is when you take an acid and a base and react them together. We're neutralizing that, and so the products, or one of the products of a neutralization reaction, is always going to be water. If you recall, probably from biology or maybe 8th grade, acids have a very low pH, so their pH is less than 7. Bases have a high pH, or a pH greater than 7. So if we mix those 2 things together, those pHs are essentially canceling each other out to get us to as close to a pH of 7 as possible, which is where water lives. So pH of 7. Plus something else. There's another product here when you mix an acid and a base. And we will do an acid-base unit where we'll talk more about neutralization reactions specifically, but in terms of the definition, we're looking for, you react an acid with a base, and one of those products is water. That's how you can identify a neutralization reaction. So, an example, we have a basic battery, which can be made if we assemble something that looks like this, and we want to identify what type of reaction this is. If we just simply look down here, we know that all single replacement reactions are going to be redox or oxidation reduction reactions, but we can prove that. This is elemental copper, so it has an oxidation number of 0. On this side, we have elemental zinc, which would have an oxidation number of 0. Here, this zinc is bonded to SO4, so if we follow the rules to identify all the oxidation states, then we would find that this zinc is a +2 oxidation state. Same thing for the copper, we would find that it is a +2 oxidation state. The SO4 doesn't really matter to us because it appears the same way on both sides. Its charge does not change. But moving from the left to the right, copper has gone from a 0 to a +2, so that is increased in charge. And then this zinc has gone from a +2 to a 0, so that is decreased in charge. And that is how we identify when we have a redox reaction. If there's a change in charge, so there was obviously movement of electrons, and that would indeed be redox or oxidation reduction. And then last question, titration, which we have done, you've either done an actual titration in class or we did a micro titration when we were using the phenolphthalein to indicate color change. So titration is just a method of taking some solution up in this thing called a burette, which is very similar to a graduated cylinder. It's got markings on it so I can read volume measurements, and I can put a solution in here, and then it's got a valve down here at the bottom that I can release some of that solution, and then based on how much I start with and how much I release, I know how much solution I actually put down into this reaction. So then if I have something else down here, I can do some math based on how much of this solution I released into my flask. So the question says, what type of reaction is a chemist investigating if drops of titrant, which is the stuff that's in here, are added to this flask until a solid appears? So if we're looking for the formation of a solid, aka a precipitate or a precipitate, then we are investigating precipitation reaction. All right, please feel free to come in and see your teacher, and don't forget to submit your photocopy or your screenshot or photo of your notes to the assignment in Google Classroom.